So now we are going to discuss, this is the last session in graphs. So in the next class we have discussed about trees, last two test question paper analysis, that is trees and graphs. So I think both of you, that is two members are joined in the class. You have to complete your exam. Suresh, you have to also complete your exam and post responses to my mail ID. So already I posted in our group. Okay.
Okay, ma'am.
Okay. Sandeep, are you completed?
Yes, no, I completed, madam.
Okay. Okay. So this is the last session on the graphs. If you have any doubts while writing exams, you can ask. Okay. Now, strongly connected components. That means, first of all, what is a connected? In the last class, we have discussed about the connected component. Means, suppose you can take any two vertices like suppose you can take any two vertices like this. Here, suppose you can take any vertices like this, x and y. So there is a path. Suppose here A, B, C, suppose D, like E. Suppose this is not a connected graph. Suppose you can find out any path between these two vertices. There is no path. Suppose you can like this here. Suppose you can find out path from A to E. So there exists some path A to B and B to C, C to D, and like this. Otherwise A to C, this is the direct, A to C and C to D and this. So this is called as a connected component. That means you can pick any two pair of vertices, there exists some path, then we can say that that is what connected component. So when we say that there is a strongly connected, and when we say that there is a unilaterally connected and weakly connected, and the graph can connected in three ways. So strongly connected means, so this is in the, this concept is here in the directed graph. So first of all, before discussing this, we are moved to weakly connected. So first of all, what is the weakly connected? So if more than one dead end in the graph, those graphs are called weakly connected. So more than one dead end in the sense, more than one dead end in the sense what? Suppose this is what, like this. Here in all these three concepts, this is the undirected graph. So all these three concepts here, from A to D, here how many endpoints are there? A to B is there and B to D is there, as well as suppose there is a path like this, A to C and C to D. So this is A to D find out chesinapudu, here path chesi A to B and D, and one more is A to C and D, otherwise A to D. So these are the three paths for A to D. And ikkada more than one dead ends. So this is a dead end. More than one dead ends, then we can call this type of graph is called as a weakly connected graph. So then what is the strongly connected graph? Here coming to the strongly connected, so there is a directed path between x to y as well as y to x. That means here x to y and y to x. Suppose you can observe here A to C and C to B, B to C is there. Suppose you can find out the path from A to B. A to B, you can find out some path. So how it is possible? So ikkada meeku path ela vastundi, A to B vachesi A to B and here C, like this. This is some graph. Suppose my intention is I can find out the path from A to C. Okay, A to B as well as C. So like that, here there is a path exists from C to B as well as B to A. That means opposite, x to y path is exists and y to x is also path exists. Then we can say that that is a strongly connected graph, strongly component or strongly connected. So in this case, this is not a strongly connected. So here suppose you can here A to B and C, A is there. suppose A to C there is no, like this. Suppose here it is, then we can say that this is the strongly connected. A to C is there, C to A is there. So that's why this is called as a strongly connected graph. And now suppose ikkada observe cheste ee rendu graphs lo, so this is what the weakly connected, and this is what just connected, not weakly connected. This is the strongly connected. And coming to the unilaterally connected, a graph is unilaterally connected if and only if it is a weakly connected plus there is a path from x to y as well as y to x. So x to y undali, y to x kuda path exist aithe ante compulsory each and every path. So like this ila ikkada oka strongly connected exist avutundi. Sorry, here strongly connected ikkada okati miss chesinamandi chudandi. Ikkada chudandi, strongly connected in the sense x to y as well as y to x rendu exist avvali. So ikkada matram x to y or y to x. Suppose this is the unilaterally and this is the strongly connected. Next, here already we have discussed the Euler's formula, so some points regarding previous concepts. Here coming to this Euler's formula for connected planar graph. Suppose Euler's formula nothing but what అండి, Euler's graph. అంటే Euler's formula దేంట్లో వర్క్ అవుతుంది అంటే Euler's graph లోనే వర్క్ అవుతుంది. అంటే Euler's graph నథింగ్ బట్ ఎడ్జెస్ ఆర్ డిస్టింక్ట్. సో ఎడ్జెస్ కనుక డిస్టింక్ట్ ఉన్నాయనుకోండి, దట్ ఈస్ కాల్డ్ యాజ్ Euler. అంటే ఆల్ వర్టిసెస్ ఉండాలి. అండ్ అందులో అంటే సపోజ్ A to D మనం పాత్ ఫైండ్ అవుట్ చేసినప్పుడు హియర్ A to B is one edge, B to C is one edge and C to D is one edge. అంటే edges are distinct, then Euler path is exist. Okay, then the Euler path is exist. Otherwise in that case this graph is called as Eulerian or Euler graph. So ilanti cases lo if the graph is Eulerian or Euler graph, so Euler formula for connected planar graph. So here what is the planar graph? Planar graph nothing but there is no cross vertices or there is no crossovers. Like this, suppose here A to B and C, this is a plane graph. And suppose A to B and next B to C, next to D, like this, and this is, suppose you can write like this. In this case this is some cross point. So now this is not non-planar. Okay, like this. Suppose A to B, C and D ఇలా ఇచ్చినాం అనుకోండి, this is not planar graph, this is a non-planar graph and this is the planar graph. How we are converted this into planar graph? There is a chance A to B and A to C is there, B to C is there and D. So there is one path from here to here. Now this is called as a planar graph. So if any graph is a planar graph, here Euler path is exists. That means that Euler, this is a Eulerian graph also. In that case, how many numbers? That means number of regions equal to this is a Euler formula. That means here R equal to E minus N plus 2. So R is nothing but number of regions. So how you find out the number of regions? This is one region, oka cycle one region, and this is another region, and this is a B, D, C, B, B to D, D to C and C to B. This is another region. So a total outer area is also another region. That means 4 regions are there. In that 3 are interior regions. 3 are the interior regions and 1 is the exterior region. That means how many number of regions are there? Total 4 regions. And coming to number of edges, here 1, 2, 3, 4, 5, 6. Total 6. Next, how many number of vertices? 4 plus 2. Okay. So this is equal to 4 plus 4. That means Euler's formula. That means any planar graph lo ee formula anedi satisfy avutundi. So this is one of the important concept. Now if this is a one example, now a complete graph Kn is planar graph if and only if n less than or equal to 4. అంటే మనకి complete graph. So this is a complete graph. Okay, suppose here this is also complete graph. So this is the planar graph and this is the planar graph. Okay, n less than or equal to 4, complete graph in the sense what? So how many number of edges are there? N into n minus 1 edges. That means every vertex degree is what, and n minus 1. That means the degree of this one is 2, this one is 2, this one is 3. Total how many number of vertices here? N equal to 3. That means each and every vertex degree is same, as well as so that vertex is adjacent to all the remaining vertices in the graph. So then we can call it as a complete graph like this. Suppose you can observe here A to B edge is there, A to C and A to D. Now B, from B, A, D, C. From C, D, A, B. From D, A, B, C. So that each and every vertex is adjacent to remaining all the vertices in the graph. Then we can call it as a complete graph. So when the complete graph, and suppose K2 is nothing but this is what the complete graph. Okay, K1 just only one vertex. So K3 is nothing but this is what the K3. So K4 is nothing but this is what the K4. That means all these three are the complete graphs. Okay, so all these three complete graphs are planar. That means a complete graph Kn is planar if and only if n less than or equal to 4. So if n less than or equal to, that means here suppose here n equal to 5. So in this case this is 1, 2, 3, 4, 5. Now it is a complete graph. Sorry, already this is the complete graph like this. So this is adjacent to all remaining 4 vertices. Now this is adjacent to all remaining 4 vertices. Now this one is adjacent to all remaining 4 vertices. You have to observe this vertex. Remaining all the 4 vertices are adjacent to this vertex, and this is all remaining 4 vertices. So here one A, B, C, D, E. These all are the vertices. Now you can convert this into a planar graph. So this is what the non-planar graph. Why? Because this is a non-planar graph. Here some crossovers are there. So these all are the cross points. So that's why this is not a planar graph. How we can convert this into planar graph? Like this. E. So now from here, this is okay. Okay. So this vertex, and then now coming to this B. So there is a chance like this. Okay, B to A is there, B to D is there, and coming to this one is there is a chance. And for this D, so this is adjacent to B, and this is adjacent to A, this is adjacent to E, and only one vertex is left over. Suppose here you can take like this, here some crossover is there. Suppose you can take like this, here some crossover is there. Suppose you can take like this crossover is there. Like that number of crossovers are there. So that we are not converted if the graph contains more than 4 vertices in the graph. So suppose that graph is a complete graph, we are not converted that into planar graph. That is non-planar only. That means a complete graph Kn is planar graph if and only if n less than or equal to 4. If it is not a planar graph, that graph is like this. Here A, B, D, E. Graph is like this. So this is the graph. So now you can convert it into a planar graph. Okay. So this is easy way. So that means from B to E. So this is the planar graph. So okay. But if it is the complete graph, then we are not converted into non-planar. Sorry, we are not converted into planar graph. And at the complete graph, if that graph contains more than 4 vertices, if that graph is a complete graph, that is not a planar graph. So in this case, you can find out whether this satisfies a Euler formula or not. Number of regions equal to number of edges, number of vertices plus 2. So here how many number of regions are there? This is one region, this is another region, and one exterior region is there. 3 regions. And total how many number of edges are there? Suppose here, this is 1 and this is 1. Okay. Now this is R1, R2, R3, R4 and R5. Total how many number of regions? 5. That means here to here A, B to C edge is there, so that this is one region and this is one region and this is one region and this is, every cycle is one region. Okay, now here how many number of edges are there? That means 1, 2, 3, 4, 5, 6, 7, 8. Total 8 edges. So number of vertices are 5 plus 2. So it is equal to 5. 5 equal to 5. This is satisfied. That means if n less than or equal to 4 only, Kn graph is a planar. So if n greater than or equal to 5, so this is not a planar graph. Kn is non-planar. So in that case Kn is non-planar. Next, so some other point here, for any graph n less than 4 vertices must planar, and any graph that is, suppose any graph here less than or equal to here write down here less than or equal to 4 vertices must planar, and any graph E less than or equal to 8 edges must planar. Okay, ఇలా ఉంటే మనకి ఆటోమేటిక్గా అది ప్లేనార్ గ్రాఫ్ అవుతుంది. సో ఎనీ ఎడ్జ్ గ్రేటర్ దాన్ ఈక్వల్ టు 5 ఆర్ edges greater than 9, so that is not planar. Planar may or may not be. So that is what I explained here. So this is here edges, number of vertices are greater than equal to 5, edges are greater than equal to 10, 5, 9. Why? Because 9 here up to 9 we can find out. That means ఇది ఒక్కటి లేకపోతే మనం ఏం చేయొచ్చు, దీన్ని we can convert అంటే here edges greater than 9. Suppose here this is the planar, this is the graph. Here how many number of edges are there? 9. 8 ఉన్నాయి. సో 8 వరకు పాసిబుల్ అవుతుంది. సపోజ్ ఇంకొకటి ఇలా తీసుకున్నాం. సో హియర్ నెక్స్ట్ సపోజ్ లైక్ దిస్. సో 9 ఉన్నాయి. ఓకే, నౌ ఏ ఇక్కడ చూడండి A2. సో మై ఇంటెన్షన్ ఈస్ B to E. సపోజ్ హియర్ B to E ఇలా ఇచ్చినాము. నెక్స్ట్ ఇలా కాకుండా A to Dని ఇలా చెప్తున్నాం అనుకోండి. హియర్ సమ్ క్రాస్ ఓవర్ ఈస్ దేర్. దట్ మీన్స్ number of vertices greater than or equal to 5, number of edges greater than 9. So then only అంటే 8 edges వరకు మాత్రమే మనం దాన్ని ప్లేనార్గా చేయొచ్చు, ప్లేనార్ గ్రాఫ్ అని చెప్పొచ్చు. దిస్ n greater than or equal to 5 may or may not be, and E greater than 9 may or may not be. That means greater than or equal to 9 is not a planar graph. And here next K m comma n. M comma n nothing but bipartite graph. That is bipartite graph nothing but you know that. So bipartite graph in the sense, suppose m comma m. So this is nothing but bipartite graph. Bipartite graph. That means here m equal to 2 and n equal to 3. Then so 2 sets and here 3 sets are there. That means this is one set. So there is an edge with another set of vertices, but not in the same set of vertices. So this is called as a bipartite graph. So there is an edge, and there is no edge from these two vertices. There is no edge from these two. There is at the same set of vertices undi manaki edge anedi form kaadu. That means K m comma n is a planar if and only if m or n less than or equal to 2. If it is greater than or equal to 3, that is not a non-planar graph. That means complete graph లో మాత్రం ఎలా చెప్తాము, ఇలా ఉంటేనే ప్లేనార్ అవుతుంది, అదర్వైజ్ కాదు. అదే if it is a bipartite graph, here m equal to m less than or equal to 2 and n less than or equal to 2. That means suppose K 1 comma 1. Now this is, so 1 comma 1 is nothing but like this. Suppose K 1 comma 2, here this is what? Planar. This is the planar graph. Suppose here 2 comma 1, nothing but this is also same like this. This is the 2 comma 1, so this is also same. And K 2 comma 2, here 2, here 2. Okay, from here to here, from here to here. So this is what a crossover. Now you can remove this crossover So how it is possible? For this, here to here and here to here, next here to here. Okay. Now there is an edge from here to here, that is possible like this. So this is a bipartite graph as well as planar graph. So this is a bipartite graph as well as planar graph. Suppose you can convert this like, suppose here like this. So here and here and here. So coming to this, here, next there is a chance here and one more chance for this. Okay, like this, from here to here and here to here and here to here. Okay, so now you can observe. Okay, here. Okay. So this is also what? Planar graph. So this is also planar graph. So అలా మనకి m equal to 2 అంటే ఓన్లీ ఈ కేస్ అంటే m equal to 2 and n equal to 2 అంటే దిస్ ఈజ్ మినిమం అండ్ దిస్ ఈజ్ మ్యాక్సిమం. అంటే మళ్ళీ ఇక్కడ ఏంటి, కంప్లీట్ బైపర్టేట్ గ్రాఫ్. అంటే సో కంప్లీట్ బైపర్టేట్ గ్రాఫ్ ఇన్ ద సెన్స్ వాట్, సో దిస్ ఈజ్ కాల్డ్ ఎస్ ఎ కంప్లీట్ బైపర్టేట్ గ్రాఫ్. దిస్ ఈజ్ ఫర్ ద కంప్లీట్ బైపర్టేట్ గ్రాఫ్. అంటే ఖచ్చితంగా ఈచ్ అండ్ ఎవ్రీ, సపోజ్ ఇలా ఉంది అనుకోండి, సో దిస్ ఈజ్ నాట్ ఏ కంప్లీట్ బైపర్టేట్ గ్రాఫ్. ఓకే, దిస్ ఈజ్ నాట్ ఏ కంప్లీట్ బైపర్టేట్ గ్రాఫ్. అంటే ఇంకా దెర్ ఈజ్ ఏ ఛాన్స్ లైక్ దిస్, ఇలా మొత్తం కంప్లీట్ చేస్తేనే దీన్ని మనం బైపర్టేట్ గ్రాఫ్ అంటాం. ఇలా రెండు ఎడ్జెస్ లేవనుకోండి, దిస్ ఈజ్ నాట్ ఏ కంప్లీట్ బైపర్టేట్ గ్రాఫ్. అంటే ఒకవేళ గ్రాఫ్ కనుక కంప్లీట్ బైపర్టేట్ గ్రాఫ్ అయితే, సో n ఈక్వల్ టు 2 n ఈక్వల్ టు 3 వరకు మనకి 2, 3 వరకు ప్లేనర్ గ్రాఫ్ అనేది సాటిస్ఫై అవుతుంది. దట్ ఈస్ n less than or equal to 2. Okay, and a graph G is connected planar simple graph, that is E less than or equal to 3n minus 6. That means if a graph is a connected planar graph, so here one example is there. So this is what the, this is not a, if it is a connected planar graph, so compulsory number of edges are less than or equal to 3n minus 1. Okay, so now see here, n equal to 5, e equal to 10. How many number of edges are here? Total ga manaki enni edges untayi? 10 edges. So that means n into n minus 1 divided by 2. Because this is an undirected graph, you can treat it as only one time. That is n into n minus 1 by 2. Total edges are 10. So sum of degrees are n into n minus 1. That means 5 into n minus 1, that is 4. Okay, here 10 less than or equal to 3 into 5, 15 minus 1, that is 9. That means 10 less than or equal to 9. This is the false because non-planar. అంటే ఏదైనా మనకి గ్రాఫ్ ఇచ్చినారనుకోండి, డైరెక్ట్గా మీరు ఇలా చెక్ చేయకుండా, కన్వర్ట్ చేసి ఇలా చెక్ చేయకుండా, డైరెక్ట్గా how many number of vertices and how many number of edges are there, just you can find, substitute in this formula. So find out whether that graph is planar or non-planar. So find out whether the given graph is planar or not. So this is the easiest way. This is to find whether the given graph is planar graph or non-planar. Okay, this is, so మనకి ఎగ్జామ్లో గ్రాఫ్ ఇచ్చేసి find out whether the given graph is planar or non-planar. So in that case ఇలా కన్వర్ట్ చేసి చెప్పాలి, takes the time. So just you can use like this. Next, for planar graphs, so this is for planar graphs, 3 greater than or equal to 3r by 2. So 3r by 2 nothing but number of regions divided by 2. Okay, that is nothing but 2e greater than or equal to 3r. Otherwise here by Euler's formula you can write like this. So how we can get, అంటే మనకి ఇది ఎలా వస్తుంది అంటే, here so we know that Euler's formula is En plus 2. This is the Euler's formula. So E less than or equal to 3n minus 6. So whether you can find out whether the given graph is planar or not. How we can get? So for that, here some formula is number of regions divided by 2. Here 2e greater than or equal to 3r. So 2e greater than or equal to 3 into e minus n plus 2. 2e greater than or equal to 3e minus n plus 2. That is, this is here minus 2e. Sorry. Here 2e minus 3e greater than or equal to minus n plus 2. So minus e greater than or equal to minus n minus 2. Okay, now sorry ikkada tappu chesam 3n 6 3n 6 now 3n 6 so minus minus so ikkada em avutundi automatic ga manaki here sorry minus తీయకుండా సో ఏం చేస్తున్నాము సో దిస్ ఈజ్ అ ఫార్ములా ఓకే దిస్ ఈజ్ వాట్ నెక్స్ట్ సో డైరెక్ట్గా ఇలా కూడా చేయొచ్చు ఇఫ్ ఇట్ ఈస్ ద ప్లేనార్ గ్రాఫ్ హౌ యూ కెన్ ఫైండ్ అవుట్ దట్ మీన్స్ ఇఫ్ ఇట్ ఈస్ ద ప్లేనార్ గ్రాఫ్ నథింగ్ బట్ సపోజ్ దిస్ ఈజ్ ద ప్లేనార్ గ్రాఫ్ ఏ బి సి హౌ మెనీ నెంబర్ ఆఫ్ రీజన్స్ 2 రీజన్స్ ఓకే ఈ గ్రేటర్ దాన్ ఈక్వల్ టు 3 ఇంటూ ఆర్ డివైడెడ్ బై 2 ఇక్కడ ఎన్ని రీజన్స్ ఎన్ని ఎడ్జెస్ ఉన్నాయి మనకి 1 2 3 edges 3 into what here 2 divided by 2 3 greater than equal to 3 suppose ఇంత ముందు కేసులో మనకి నెంబర్ ఆఫ్ ఎడ్జెస్ 8 ఉన్నాయి అండ్ రీజన్స్ వచ్చేసి 5 ఉన్నాయి సో ఇంత ముందు మన ప్రాబ్లం చూసాం ఎగ్జాంపుల్లో సో హియర్ దట్ ఈస్ నెంబర్ ఆఫ్ ఎడ్జెస్ 8 edges greater than or equal to here 3 into number of reasons 5 divided by 2 that is 8 greater than or equal to 3 into 5 that is 15 divided by 2 nothing but 7.5 so this is also satisfied okay so next one if G is a connected simple graph plus number of triangles that means ikkada ఒకవేళ G is a connected simple graph this minimum cycle అంటే ఇక్కడ మినిమం సైకిల్ లెంత్ వచ్చేసి మనకి 4 minimum cycle length is 4 that means number of vertices are 4 okay now ఇలా ఉన్నప్పుడు that means if it is a connected simple graph in the sense suppose if it is a connected simple graph this is a connected simple graph means there is no self loops okay so in this case how it is that means E greater than equal to 4r by 2 4r by 2 that means this is the formula okay so if it is a planar graph E greater than or equal to 3r divided by 2 so if it is a connected simple graph E case lo E greater than or equal to 4r by 2 and complete planar graph if it is a complete planar simple graph maximum value of minimum degree ante maximum value of minimum degree nothing but suppose ila graph undi manaki suppose here A B C D E A ఇలా ఉంది సో ఇక్కడ డిగ్రీ చూడండి నేను ఇలా ఇస్తున్నాను ఫ్రమ్ హియర్ టు హియర్ సపోజ్ ఇక్కడ అంటే ఫస్ట్ స్టేట్మెంట్ చూడండి సో కంప్లీట్ ప్లేనార్ CPS that means connected simple graph maximum value of minimum degree ఖచ్చితంగా ఎలా ఉండాలంటే లెస్ దాన్ ఈక్వల్ టు 5 ఉంటుంది దట్ మీన్స్ సపోజ్ హియర్ సింపుల్ ఏ బి ఇలా ఉంది సో ఇలా మనకి గ్రాఫ్ దిస్ ఈజ్ అ కనెక్టెడ్ గ్రాఫ్ అంటే సపోజ్ మ్యాక్సిమం మనం ఎంతవరకు కనెక్ట్ చేయొచ్చు దీన్ని ఇక్కడ 1 2 3 4 5 సో ఆల్రెడీ 2 times ఇచ్చాము ఓన్లీ కౌంట్ ఇట్ యాజ్ 1 time 1 2 3 4 అంటే 4 ఓకే నెక్స్ట్ ఇది కంపల్సరీ ఏమవుతుంది అంటే మినిమం డిగ్రీ అంటే ఈ డిగ్రీ 4 ఉంది ఈ డిగ్రీ దీనికి వచ్చేసి 2 ఉంది దీనికి 3 ఉంది లైక్ దట్ మనం ఇలా కన్వర్ట్ చేసినప్పుడు డిగ్రీ మినిమం డిగ్రీ అనేది ఖచ్చితంగా కనెక్టెడ్ కాంపోనెంట్ అవుతాయి అంటే దిస్ ఈజ్ ద కనెక్టెడ్ కాంపోనెంట్ సో ఇందులో మినిమం డిగ్రీ ఖచ్చితంగా మనకి లెస్ దాన్ ఈక్వల్ టు 5 ఉంటుంది సో ఇక్కడ నంబర్ ఆఫ్ దట్ మీన్స్ ఇఫ్ దెర్ ఈస్ నో ట్రయాంగిల్స్ ఇందులో కనుక ట్రయాంగిల్స్ ఏమీ లేవు అనుకోండి అంటే సపోజ్ దిస్ ఈజ్ 1 ట్రయాంగిల్ సో ఈ ట్రయాంగిల్స్ ఏమీ లేకపోతే అప్పుడు డిగ్రీ వచ్చేసి దిస్ ఈస్ ఓకే అలాగే దిస్ ఈస్ వాట్ ద గ్రాఫ్స్ అండ్ ట్రీస్ పైన సమ్ కాన్సెప్ట్స్ ఆల్రెడీ వీ ఆర్ డిస్కస్ దీస్ కాన్సెప్ట్స్ సో సమ్ న్యూ పాయింట్స్ ఆల్సో దేర్ ఏ గ్రాఫ్ ఈజ్ ఏ సైకిల్ ఇఫ్ అండ్ ఓన్లీ ఇఫ్ ఇట్ ఈస్ కనెక్టెడ్ అండ్ అసైక్లిక్ ఏ గ్రాఫ్ అనేది ఏంటి అంటే సో ఇట్ ఈజ్ ఏ కనెక్టెడ్ అండ్ అసైక్లిక్ A graph is a tree if and only if it is connected and acyclic. So connected and acyclic, nothing but connected in the sense is no only I can say that this is what the connected. Okay, suppose you can take any two pairs. So from this is A, this is B, C, D, E. Suppose there is a path from this is what C to D, C to D. So there is a path exists from like this C to B and A and E. So this is some path like that. You can pick any two, but it says path is exists. So that's why this is called as a connected component. And there is acyclic. That means suppose here from here to here edge is there. This is called as a cycle. So if there is no cycles, this is called as acyclic. That means so tree is nothing but there is a connected component and acyclic graph. So a graph is a graph is what cyclic. A graph is a tree if and only if it is connected and n-1 edges. We know that. So a graph is a tree if it is acyclic and n-1 edges. So here for all x comma y belongs to, there exists one path x and y, then it is a tree. Suppose you can take any graph. So there exists a path from A to E. Suppose here A to E. So A to E is there and A to F and F to E is there and A to D, D to E is there, like this. Number of paths are existed between two vertices, that is called as a graph. Okay, whereas in the tree there exists only one unique path between two vertices, then we can call it as a tree. Okay, a graph is a tree if and only if minimally connected. That means connected components. See here only one connected component is there. So whereas in the graph number of connected components are there. So in the tree equal to n minus L cut vertices are there. That means cut vertices in the sense, suppose here this is a tree like this. Suppose this is a cut vertex. Okay, and this how many number of cut vertex are there? ఇక్కడ మనకి this is the cut vertex. Suppose here means n minus L cut vertices. That means 1 అంటే ఈ గ్రాఫ్ ని మనం డిస్కనెక్ట్ చేయాలి అంటే here from here to here some path is exist and this is. So now this path, this vertex is removed. Now this is one component, this is one component, this is one component, and it can convert into 3 components. So how many number of cut vertices are there in this graph? That means n minus L. That means 5 minus here 1 2 3 4 5 minus L. How many number of are there here? 3 means 2. అంటే sometimes మనకి ఇది కూడా రిమూవ్ చేయొచ్చు. సో రూట్ కూడా రిమూవ్ చేయొచ్చు. సో అప్పుడు ఏమవుతుంది మనకి అంటే మ్యాక్సిమం ఎన్ని కాంపోనెంట్స్, ఇది 3 కాంపోనెంట్స్గా వస్తుంది. సో ఇలా అంటే మ్యాక్సిమం అంటున్నాం, కంపల్సరీ చెప్పట్లేదు, మ్యాక్సిమం 2. So that's why 1 or 2. ఈ ఫిగర్ ఈ పర్టికులర్ ట్రీకి how many number of cut vertices are there? 1 or 2. That means maximum 2 cut vertices. So tree equal to n minus L cut vertex when it is bipartite. Okay, a tree with 2 or more vertices always bipartite. So tree is a one line connected. That means suppose here this is bipartite. So this is one set to other set. So this is one set to other set. So that's why this is called as a bipartite. Okay. So pulling the edge between any pair will create a cycle. It is called fundamental cycle. Suppose illa manaki tree తీసుకున్నప్పుడు suppose you can put any edge between these two. So like this. here. So now it is a cycle. So now this is called as a fundamental cycle. A tree with n nodes has how many number of fundamental cycles are there? So tree lo manaki enni fundamental cycles undochu? So tree lo suppose this is some tree here like this. This is one tree. Suppose here for making the cycle here, and this is one, and this is one, and this is one, like that. Three fundamental, that means this is one cycle, and this is one cycle, and this is one cycle, total is one cycle. So from here to here is one cycle, like that. How many number of cycles are there? Suppose ikkada simple ga తీసుకున్నారు అనుకోండి, ఇక్కడ ఏమవుతుంది, వన్ సైకిల్ ఉంటుంది. ఓకే, లైక్ దట్ మనకి ఎన్ని సైకిల్స్, దట్ మీన్స్ NC2 అంటున్నాడు. ఓకే, NC2 means 3C2, that is 3 factorial divided by here a tree with n nodes has NC2 fundamental cycles. That means n factorial divided by n minus 2 factorial. That means total ga ante manaki ikkada a tree with n nodes has NC2 fundamental cycles. సో NC2 ఫండమెంటల్ సైకిల్స్ అంటే ఇక్కడ ఇంకొకటి ఏంటి అంటే కాన్సెప్ట్, ఇక్కడ మనకి ఇది బైనరీ ట్రీనా కాదా కూడా అబ్జర్వ్ చేయాలి. సో ఇక్కడ సపోజ్ హియర్ MRA ట్రీ ఈజ్ దేర్. MRA ట్రీ మీన్స్ మోర్ దాన్ 1 children, more than 2 children, 1 2 3 4 like that. A tree has at most less than equal to m children. ఇది ఒక్కసారి నేను ఈ పాయింట్ మళ్ళీ ఎక్స్ప్లెయిన్ చేశాను, ఇట్లా అండి. So MRA tree, so this is what the MRA tree. Here 2 children are there, here 3, here 4. So a tree has at most less than equal to m children. So less than equal to m children. So every vertex is 0 less than equal to b less than equal to m. So internal vertexes ఎన్ని ఉంటాయి దీనికి అంటే 1, అంటే ఇది అంటే దిస్ ఈజ్ 0. మనకి ఎవ్రీ వర్టెక్స్కి చిల్డ్రన్ ఉండొచ్చు, ఉండకపోవచ్చు. ఎట్ మోస్ట్ ఎన్ని చిల్డ్రన్స్ ఉండొచ్చు అంటే లెస్ దాన్ ఈక్వల్ టు m చిల్డ్రన్. అండ్ ఇంటర్నల్ నోడ్స్ ఎన్ని ఉంటాయంటే 1 to less than equal to m. సో లైక్ దిస్. సపోజ్ హియర్ లైక్ దిస్. ఇక్కడ చూడండి 1 నుండి ఎన్ని చిల్డ్రన్స్ అయినా ఉండొచ్చు. దిస్ ఈజ్ కాల్డ్ ఇస్ ఎ 3 array ట్రీ. ఓకే, 3 array ట్రీ. సపోజ్ ఇలా ఉంది. సో లైక్ దిస్. ఇక్కడ 2 ఉన్నాయి. సో ఇక్కడ ఒకసారి మనకి ఇలా ఉన్నాయనుకోండి. సో ఇక్కడ 4 ఉన్నాయి. సో ఇప్పుడు ఏమవుతుంది, మ్యాక్సిమం 4 కాబట్టి 4 array అవుతుంది. అంటే ఇక్కడ ఇంటర్నల్ నోట్స్ మనకి ఒకవేళ దీనికి ఇలా ఇచ్చుకుంటూ వెళ్ళామనుకోండి, ఇంటర్నల్ నోట్స్ ఏమవుతాయి మనకి, ఈ ట్రీకి ఇంటర్నల్ నోట్స్ ఎప్పటి వరకు ఉంటాయి, ఈ సబ్ ట్రీ అబ్జర్వ్ చేస్తే లెస్ దాన్ ఈక్వల్ టు 4. ఓకే, ఒకటి మాత్రం మినిమం. సో లెస్ దాన్ ఈక్వల్ టు 4. ఓకే, సో దీనికి మనకి ఏంటి, లీఫ్ తీసుకుంటే నోడ్ ఉండొచ్చు, ఉండకపోవచ్చు. దట్ మీన్స్ 0 but less than equal to number of vertices up to m. Okay, and next fully array tree. Full binary tree anatledu, fully array tree antunnam. So full array tree is nothing but 0 or m children. That means suppose here ఇలా ఇచ్చాం. సో దిస్ ఈజ్ అ ఫుల్. అన్ని కంపల్సరీ మనకి m చిల్డ్రన్ అనేది ఎగ్జిస్ట్ అవ్వాలి. m చిల్డ్రన్స్ కంపల్సరీ 0 ఆర్ m చిల్డ్రన్. సో అదర్వైజ్ అంటే సపోజ్ లైక్ దిస్. హియర్ సపోజ్ ఇక్కడ మనకి ఇలా ఇలా ఇచ్చేసాము. ఓకే, నౌ ఇలా ఉంది. సో దిస్ ఈజ్ ద ఫుల్ అర్రే ట్రీ. అంటే ఇక్కడ మనకి 0 ఉంది, అంటే వీటికి చిల్డ్రన్స్ లేరు. ఐదర్ చిల్డ్రన్ 0 అన్నా ఉండాలి, m అయినా ఉండాలి. అంటే ఇక్కడ వరకు ఫుల్ అవుతుంది. సో ఇక్కడ చూడండి, మరి దిస్ ఈజ్ ఇక్కడ వరకు ఫుల్ అవుతుంది. సో ఇది టోటల్ అబ్జర్వ్ చేస్తే కాదు, మళ్ళీ ఇక్కడ కూడా ఉండాలి. సో దెన్ ఓన్లీ వీ కెన్ కాల్ ఇట్ యాజ్ ఏ ఫుల్ అర్రే ట్రీ. సో కంప్లీట్ అర్రే ట్రీ, ఎవ్రీ లెవెల్ హ్యాస్ మ్యాక్సిమం m చిల్డ్రన్ ఎక్సెప్ట్ సెకండ్ లాస్ట్ లెవెల్, బట్ ఇట్ ఈస్ లెఫ్ట్ సాటిస్ఫైడ్. దట్ మీన్స్ లైక్ దిస్. ఓకే, సపోజ్ ఇలా ఉంది అనుకోండి. సో ఇప్పుడు దీన్ని ఎప్పుడు కంప్లీట్ అంటామంటే ఇలా ఉండాలి. ఓకే, సో సపోజ్ ఇలా ఉంది అనుకోండి, దిస్ ఈజ్ నాట్ ఏ కంప్లీట్. సో లైక్ దిస్, లెఫ్ట్ సాటిస్ఫైడ్. ఇక్కడ 0 ఉన్నా పర్లేదు, బట్ లెఫ్ట్ సాటిస్ఫైడ్ కావాలి. ఓకే, ఇప్పుడు దిస్ ఈజ్ ఇన్ దిస్ కేస్ n ఈక్వల్ టు i ప్లస్ l ఇంటర్నల్ నోట్స్. సో అప్పుడు ఎన్ని ఇంటర్నల్ నోట్స్ ఉంటాయి, i అనేది ఏంటి అంటే నంబర్ ఆఫ్ నోట్స్, i ప్లస్ l. సో ఇక్కడ l ఏంటి, 1 2 3 4 5 6 7. ఓకే, 7 ఉన్నాయి అండ్ ఇంటర్నల్ నోడ్స్ ఎన్ని 4 ఉన్నాయి. సో టోటల్ ఎన్ని నోడ్స్ ఉన్నాయి 11 నోడ్స్ 1 2 3 4 5 6 7 8 9 10 సారీ ఇంటర్నల్ నోడ్స్ 4 అండ్ లీవ్స్ వచ్చేసి 1 2 సారీ ఇంటర్నల్ నోడ్స్ 3. దిస్ ఈజ్ ద లీఫ్ ఓన్లీ, ఇంటర్నల్ నోడ్స్ 3. సో టోటల్ వచ్చేసి దిస్ ఈజ్ దట్ ఈజ్ నథింగ్ బట్ m ఈక్వల్ టు ఇంటర్నల్ నోడ్స్ ప్లస్ లీఫ్ నోడ్స్, ఇంటర్నల్ నోడ్స్ ప్లస్ లీఫ్ నోడ్స్. సో అదర్వైజ్ ఇలా కూడా చెప్పొచ్చు n ఈక్వల్ టు mi ప్లస్ 1. ఓకే, సో mi నథింగ్ బట్ internal nodes, m is the array and plus 1, that is nothing but here n equal to mi plus 1. Here m is nothing but 3 array, internal nodes ఎన్ని 3 ఉన్నాయి. సో plus 1 internal nodes 3 ఉన్నాయి. This is the what 3 array tree plus 1, that means total ఎన్ని ఉన్నాయి 10 nodes. So these are the important formulas. Okay, so now I will start here only.